Hello dear students, welcome to the Security of Information Systems, Lecture 11. Today's topic is,
Network perimeter security.
okay, let's start. The outline is as follows for today's lectures.
Firewalls, routers, proxies, architectures, intrusion detection systems, host-based, network-based, dealing with false alarms, wireless LAN access control, evolution and history, WPA2, robust security network architecture, RNS.
Okay,
Perimeter security analogy medieval castle defenses.
this is an analogy to understand what is about perimeter security. You see there are observation posts at the most outer walls. There are guards. There is normal access gate, which has only one access, as you can see. It has breach, gatehouse here, and we have outer wall. Then we have inner wall as another security level. Then you see there is outer court, mode, and inner court. Perimeter security is some similar to this one.
Defending local networks network perimeter security.
So you see there is one access to our system. So this is our system. You see this line represent our system, and we have access to internet, normal access. And first we have firewall. You see here, and we have gateway and router, and packet filter at the first gate. So the internet access starts from here, and we separate our network to two parts. First one is external network. Okay, it is it is called as demilitarized zone. Let's look for definition.
In computer security, a DMZ or demilitarized zone, sometimes referred to as a perimeter network or screened subnet, is a physical or logical subnetwork that contains and exposes an organization's external-facing services to an untrusted, usually larger, network such as the Internet. The purpose of a DMZ is to add an additional layer of security to an organization's local area network LAN. An external network node can access only what is exposed in the DMZ, while the rest of the organization's network is firewalled. 1. The DMZ functions as a small, isolated network positioned between the Internet and the private network. 2. The name is from the term demilitarized zone, an area between states in which military operations are not permitted.
Okay, here the function is this one.
The DMZ functions as a small, isolated network positioned between the Internet and the private network.
Here we can see that this is the area which has access to the internet, and then we have internal network. So in our DMZ area, we have DNS server, mail server, web server, which servers has to have access to internet. And we have honeypot. We will see about honeypot. We have switch, and we have IDS, which is intrusion detection systems. And then we have another firewall, and it has router and proxy. Then our internal network starts, which is our most crucial and important network. There are production servers, workstations, and another intrusion detection system, and database, and another switch. So this is the kind of, let's say, illustration of network perimeter security. Okay, let's start with firewalls.
Network perimeter security method, firewalls. A firewall is a checkpoint that protects the internal networks against attack from outside networks. The checkpoint decides which traffic can pass in and out based on rules.
You see external network which has potential threats, internet, and we have firewall. It is equivalent of checkpoint, and we have internal resources. Okay. Firewalls also do more things, but we will cover them as we see.
Firewalls, Overview 1. If the risk of having a connection to the internet is unacceptable, the most effective way of treating the risk is to avoid the risk altogether and disconnect completely. If disconnection from the internet is not practical, then firewalls may provide an effective level of protection that can reduce the risk to an acceptable level. Firewalls are often the first line of defense against external attacks, but should not be the only defense. A firewall's purpose is to prevent unauthorized access to or from a private network.
Okay, so the best protection is disconnecting from internet. However, if it is not possible, firewalls may help us to defend against external attacks, but it should not be the only defense we have. The firewall purpose is preventing unauthorized access or from a private network access. Okay.
Firewalls, Overview 2. All traffic entering or leaving must pass through firewall. The network owner must define criteria for what is unauthorized.
This means that we have to define criteria for both what is unauthorized and or authorized. Okay.
The effectiveness of firewalls depends on specifying authorized traffic in terms of rules. The rules defines what to let pass through, the rules defines what to block.
Okay.
Firewalls must be effectively administered, updated with the latest patches and monitored. Firewalls can be implemented in both hardware and software, or a combination of both.
This is important. Usually they are combination of both, but you can have hardware firewall or software firewall as well.
Types of firewall technology, vehicle analogy.
So from a vehicle point of view, if we look to firewall as an analogy, the packet filters firewall is like inspects packet headers only. So in the vehicle analogy, the packet header is being its plate number, you see. So this packet filter firewall only checking the vehicle plate number of a vehicle and does nothing else. It doesn't check what is inside. There may be armored man inside a car. However, packet filter will not check that. Therefore, it will take in an armored man of full of armored man in a car. Okay, for example. Then there is stateful packet filters, which analyzes bidirectional traffic. Therefore, in this case, it will check from where the vehicle is coming and to where it is going. And then application layer proxy, which splits connection, inspects payload and analyzes traffic. You see in application layer proxy, it checks what is inside the car as well. And then there is next generation firewall, end-to-end connection, inspects payload and analyzes traffic. We will see more about them. So the types of firewall is like this. You see simple packet filter is like this, end-to-end transport connection and end-to-end transport connection, then end-to-end transport connection and state info. And the proxy is internal transport connection, application, external transport connection, and next generation firewall, internal transport connection and external transport connection. Okay, let's continue.
Stateless packet filter.
So we will now see the details of these types of firewalls. Okay.
A packet filter is a network router that can accept, reject packets based on headers. Packet filters examine each packet's headers and make decisions based on attributes such as source or destination IP addresses, source or destination port numbers, protocol UDP, TCP or ICMP message type, and which interface the packet arrived on, unaware of session states at internal or external hosts, high speed but primitive filter.
You see, with a stateless packet filter, we can block certain IPs, certain IP ranges, and we can block certain ports and certain port ranges or such. Actually, it can be pretty useful because if you block unnecessary ports, you would automatically improve your security. And if you block certain IP addresses, you may prevent certain websites to be accessed, or it is both valid for from incoming and outgoing traffic. It can also check the ICMP message type. So let's look for what is ICMP message type. I also don't know. So okay.
Internet Control Message Protocol (ICMP) is a supporting protocol in the Internet Protocol Suite. It is used by network devices, including routers, to send error messages and operational information indicating success or failure when communicating with another IP address. For example, an error is indicated when a requested service is not available or that a host or router could not be reached. 2. ICMP differs from transport protocols such as TCP and UDP in that it is not typically used to exchange data between systems, nor is it regularly employed by end-user network applications, with the exception of some diagnostic tools like ping and traceroute.
Okay, I see. And which interface the packet arrives on? Interface is about this. Okay, anyway, let's continue. So the stateless packet filter is high speed but primitive filter. Then we continue.
Widespread packet filter software, Linux. IP tables, NetFilter, NFT, NT tables. Examples: IP tables. IP tables A forward S131.234.142.33J accept. All packets from source IP address 131.234.142.33 are accepted. IP tables A forward PTCPD 10.0.0.56, D port 22J accept. All packets using transport protocol and destination address 10.0.0.56 and destination port 22 are accepted.
So you see, it is pretty easy to define an IP table and allow certain IP, certain port and protocol or such. Okay.
Problems with stateless filtering. Assume a typical security policy: access from internal to external allowed, access from external to internal prohibited. Example application: home network.
You see, this is true in our home network. We are usually not allowed to have access from external to internal. What does this mean? That usually in your home network you cannot, for example, become a host to a website because your ISP does not allow you to do that, or you may not set your home network as an mail server to send emails, because usually your ISP also blocks that or such. So this is a typical security policy. But we are connecting to website, but it is from with our internal to external policy.
Naive packet filter configuration. Outgoing packet forward, incoming packet reject.
Okay, I will pause for a moment. Okay, stateful filtering, internet and internal network. You see TCPs, SAN and DSTX.
TCP, SYN, DSTX.
Okay.
TCP, SYNAC, SRCX.
Okay.
UDP, DNS request, DSTY.
Okay.
UDP, DNS response, SRCY.
Anyway, it's not much explanatory there.
Stateful packet filters. Stateful packet filters track current state of a connection. More intelligent than simple packet filters. Stateful packet filters keep track of sessions. Recognize if a particular packet is part of an established connection by remembering recent traffic history. We'll add a temporary rule to allow the reply traffic back through the firewall. When session is finished, the temporary rule is deleted. This makes the definition of filtering rules easier to accomplish and therefore potentially more secure. High speed can use relatively advanced filter rules. Requires memory, so can be subject to DOS, denial of service attacks.
Okay. So these are the states of packets. You see, from internal network to internet, there is a TCP synchronization packet. And let's see the states of IP packets. This is more related to network. Okay, so these are the TCP states, and with stateful filtering, where the firewall is able to keep the states and take action according to them. Let's read the states.
Closed. There is no connection. Listen, the local endpoint is waiting for a connection request from a remote endpoint, i.e. a passive open was performed. Established. The third step of the three-way connection handshake was performed. The connection is open. FIN wait 1, the first step of an active close four-way handshake was performed. The local endpoint has sent a connection termination request to the remote endpoint. Close wait, the local endpoint has received a connection termination request and acknowledged it, e.g. a passive close has been performed and the local endpoint needs to perform an active close to leave this state. FIN wait 2, the remote endpoint has sent an acknowledgement for the previously sent connection termination request. The local endpoint waits for an active connection termination request from the remote endpoint. Last ACK, the local endpoint has performed a passive close and has initiated an active close by sending a connection termination request to the remote endpoint. Closing, the local endpoint is waiting for an acknowledgement for a connection termination request before going to the time wait state. Time wait, the local endpoint waits for twice the maximum segment lifetime (MSL) to pass before going to close to be sure that the remote endpoint received the acknowledgement.
Okay. Let's continue with stateful packet filters.
Examples: iptables a forward m state new I eth 0 j accept new connections, i.e. TCP SYN from network interface eth 0 from inside.
Okay, add 0 is attendant 0 from inside and accept TCP SYN packages. So let's look for TCP SYN. Okay. Okay, you see there is also TCP SYN attack. Okay, one moment. Okay, and so you see the SYN is synchronization message. So the attack. So you see there is TCP sync flood, which is an attack type. Let's read that as well.
What is a SYN flood attack? TCP SYN flood, aka SYN flood, is a type of distributed denial of service (DDoS) attack that exploits part of the normal TCP three-way handshake to consume resources on the targeted server and render it unresponsive. Essentially, with SYN flood DDoS, the offender sends TCP connection requests faster than the targeted machine can process them, causing network saturation. Attack description: when a client and server establish a normal TCP three-way handshake, the exchange looks like this. Client requests connection by sending SYN synchronize message to the server. Server acknowledges by sending SYN ACK synchronize acknowledge message back to the client. Client responds with an ACK acknowledged message and the connection is established. In a SYN flood attack, the attacker sends repeated SYN packets to every port on the targeted server, often using a fake IP address. The server, unaware of the attack, receives multiple, apparently legitimate requests to establish communication. It responds to each attempt with a SYN ACK packet from each open port. The malicious client either does not send the expected ACK, or, if the IP address is spoofed, never receives the SYN ACK in the first place. Either way, the server under attack will wait for acknowledgement of its SYN ACK packet for some time.
So you see, you are able to spoof your IP when sending packages. You just remove the header and put a fake IP when sending the SYN command. Therefore, the server thinks that you are some other IP and with a single IP you can spoof the and exhaust the server. It is like this: the attacker sends multiple SYN requests, the server open a port, and server has only so many ports, so it is not countless, and opens the port and starts waiting for acknowledgement message and sends, you see, the server sends sync acknowledgement message back to the client, but it never arrives to the attacker because the attacker has already spoofed its IP, and therefore the connections of the server exhaust the number of ports ends.
During this time, the server cannot close down the connection by sending an RST packet, and the connection stays open. Before the connection can time out, another SYN packet will arrive. This leaves an increasingly large number of connections half-open, and indeed SYN flood attacks are also referred to as half-open attacks. Eventually, as the server's connection overflow tables fill, service to legitimate clients will be denied, and the server may even malfunction or crash. While the classic SYN flood described above tries to exhaust network ports, SYN packets can also be used in DDoS attacks that try to clog your pipes with fake packets to achieve network saturation. The type of packet is not important. Still, SYN packets are often used because they are the least likely to be rejected by default.
Okay, there are methods of mitigation as well. Let's learn them too.
Methods of mitigation. While modern operating systems are better equipped to manage resources, which makes it more difficult to overflow connection tables, servers are still vulnerable to SYN flood attacks. There are a number of common techniques to mitigate SYN flood attacks, including micro blocks. Administrators can allocate a micro record, as few as 16 bytes, in the server memory for each incoming SYN request instead of a complete connection object. SYN cookies. Using cryptographic hashing, the server sends its SYN ACK response with a sequence number (SICNO) that is constructed from the client IP address, port number, and possibly other unique identifying information. When the client responds, this hash is included in the ACK packet. The server verifies the ACK, and only then allocates memory for the connection. RST cookies. For the first request from a given client, the server intentionally sends an invalid SYN ACK. This should result in the client generating an RST packet, which tells the server something is wrong. If this is received, the server knows the request is legitimate, logs the client, and accepts subsequent incoming connections from it. Stack tweaking. Administrators can tweak TCP stacks to mitigate the effect of SYN floods. This can either involve reducing the timeout until a stack frees memory allocated to a connection, or selectively dropping incoming connections. Obviously, all of the above-mentioned methods rely on the target network's ability to handle large-scale volumetric DDoS attacks, with traffic volumes measured in tens of gigabits and even hundreds of gigabits per second.
Okay, so we now know what is TCP SYN, and we can accept requests from certain IP with this command to our firewall.
IP tables A forward M state established, related J accept. Accept all packets which belong to an established TCP connection or are related to an existing UDP communication. Stateful packet filter evaluation. Strengths: low overhead and high throughput, supports almost any application. Weaknesses: unable to interpret application layer data, commands, may allow insecure operations to occur, allows direct connection between hosts inside and outside firewall.
Okay.
Personal firewalls. A personal firewall is a program that is designed to protect the computer on which it is installed. Personal firewalls are frequently used by home users to protect themselves from the internet.
Okay, uses such as Kaspersky Internet Security has a personal firewall, and I think we can see it from more details. And let's see, cloud protection quarantine, file antivirus, web antivirus, mail antivirus, network attack blocker, UC firewall.
Nowadays, for example, included in Windows. Advantage compared to network firewall, rules can take applications into account.
It is true, you can block connections or allow connections based on applications and such in, for example, both Kaspersky Internet Security or the firewall of the Windows. You see, Windows 10 has firewall and network protection. Like this, you can set rules. You see, allow and after firewall, network and internet troubleshooter and such. Okay.
PV4 Network Address Translation, NAT.
Okay, IP for, let's see.
NAT used to increase IPv4 address space. Translates public IPADDR. Left-right arrow private IPADDR. And ports.
Currently we are all on NAT, actually CG NAT, because the IP4 addresses that we use are extremely limited. Actually, they are exhausted. Therefore, our internet service providers are using a single IP to make sometimes tens of, sometimes hundreds of users to connect the internet. For example, today the Discord was banned my IP address even though I didn't do anything, because our IP is shared with maybe 100 another customer. Therefore, the Discord, for example, sees that I am doing attacks to the Discord network, because when maybe thousands of requests come from the single IP, they may see that as I am an attacker. So this is done by not translation. It's an advanced topic. However, let's try to understand it in a short time.
Each local network can reuse private IP address ranges. Artificially increases the number of usable IP addresses. Possibilities. Static mapping, permanent mapping of public to private address, no gain. Dynamic mapping. Mapping of public to private address when needed, unmapped when no longer needed. PAT port address translation, multiple internal addresses mapped to same public address but with different port number.
Okay, this is what is being used. You see here, I will try to explain you. We have one public internet access, IP address that we are all being connected to. And our internal network is being the network of our internet service provider, okay, such as Super Online or TTNet. And internally, our internet service provider assign us a private IP address and a private port. So with combination of these private IP address and private port, they are able to differentiate the outgoing ports and incoming connections. For example, it assigns the public port 5001 to me, 5002 to another customer, 5003 to another customer. Therefore, with different public port assignment, they can map which connection belongs to the which client. Okay, so with this way they can even connect 1000 or 10,000 of different computer to the same public internet IP address. This has so many drawbacks, of course. For example, what has happened to me today, the Discord had banned me, or if another client commits a crime through this public IP address, and if there are no proper records held in my ISP, they may not convert who has committed that crime. And if the remote server which holds the uh, which where the crime committed does not keep the incoming connection public port, then that still cannot be translated to the who has committed that crime, and so and such. This is really an advanced topic, and if you wonder how it works, you can look for articles. I will show you some. I will find a good article for you to read. Okay, for example, this article is good. You may read this, how it works. Anyway, so you see here, host 10001. For example, it is the client 1. Okay, sends datagram to this remote IP from port 80. Then this connection request is opened with the internal port 3345 to the destination this IP address with public port 80. Okay, then it goes to the internal switch. Okay, and this switch, you see 10004, translate this request to the some public request, you see, with public request to to our public IP address and with the public port 5001. When the remote server sends back the data with 5001 public port, the switch translates this to back to us to server client 1. So the public port here is being the determiner of who has sent, and by using this our private network, which is our internet service provider, finds who has sent that request. Okay.
IPv4 NAT plus and advantages: helps enforce control over outbound connections, helps restrict incoming traffic, helps conceal internal network configuration, makes port scanning more difficult. Can't be used with protocols that require a separate back channel, protocols that encrypt TCP headers such as IPsec, embedded TCP address info, not recommended with IPv6.
There are also some other disadvantages. You may also look for them on the internet.
Application layer proxy. 1. External client sends a request to the server, which is intercepted by the outwards-facing firewall proxy 2. Inwards-facing proxy sends request to server on behalf of client. 3. Server sends reply back to inwards-facing firewall proxy. 4. Outwards-facing proxy sends reply to the client. Client and server both think they communicate directly with each other, not knowing that they actually talk with a proxy. The proxy can inspect the application data at any level of detail, and can even modify the data.
So you see there is there is outwards facing proxy here, the orange box, and there is inwards facing proxy, which is green one. So when client wants to communicate with server, actually it communicates with proxy. However, it is not being aware of it is communicating with the proxy. Okay. So this is application layer proxy.
Next generation firewalls NGFW inspects payload in end-to-end or proxy application connection. Support specific application protocols, e.g. HTTP, Telnet, FTP, SMTP, etc. Each protocol supported by a specific proxy HW, SW module.
This is hardware and this is software.
Can be configured to filter specific user applications. E.g. Facebook, YouTube, LinkedIn, can filter detailed elements in each specific user application.
And for example, if you are connected behind an application layer firewall, your data can also be read by the firewall. Okay. Therefore, if you have installed the firewall root certificate, the administrator can see even the content of your HTTPS connection. We will see about that. You see.
Can support TLS, SSL encrypted traffic inspection, can provide intrusion detection and intrusion prevention. Very high processing load in firewall. High volume needs high performance hardware, or else will be slow.
You see, it has of course very high processing load because it inspects every packet inside.
High performance NGFWs. High range model, PA7050 up to 120 gigabits per second throughput prices starting from 200,000 United States dollars.
And by the way, this is probably old and outdated right now, but you get the idea. These prices are not extreme, they are real.
High range model, 61,000 security system up to 400 gigabits per second throughput prices starting from 200,000 United States dollars.
Let's look for price. Okay, let's look for some up-to-date prices. Okay, they are not showing here. Let's look. You see, these are very low true outputs. It is not even 1 gigabit per second, and list price is $1,200. And let's look for something good. Okay, for example, 75 gigabit per second. You see, it is $250,000, and this is not even 100 gigabits per second. If you get something 1 terabits per second, oh, this is not that. You see, they are extremely expensive. Such firewalls are extremely expensive. You see, these are the models, but their prices are not included here. Anyway, you get the idea. They are extremely expensive. One moment. Okay.
Inline deep packet inspection. Deep packet inspection looks at application content instead of individual or multiple packets. Deep inspection keeps track of application content across multiple packets. Potentially unlimited level of detail in traffic filtering.
You see, with deep inspection, they can see the payload data as well. And what is the content of the received message, received traffic. It checks IP header, UDP header, payload data.
TLS, SSL encrypted traffic inspection in firewalls. TLS designed for end-to-end encryption, normally impossible to inspect. In order to inspect TLS, proxy must pretend to be external TLS server. Proxy creates proxy server certificate with the name of external server, e.g. facebook.com, signed by local proxy root private key, assumes that local proxy root certificate is installed on all local hosts. The proxy server certificate is automatically validated by local client, so user may believe that she has TLS connection to the external server.
Okay, so you see, for this to work, local proxy root certificate has to be installed on your computer or device. If it is not installed, you would get an error message from your browser. Therefore, for example, if you are working in a company and company has provided you a computer, your HTTPS traffic may not be secure as you might think, because they may read your traffic content as well if they have installed a proxy root certificate to your computer or device. Okay, so it works like this. Client request data from server, for example from Facebook. Our request go to first proxy B, which has internet PKI root certificates. Then the server sends back the TSL encrypted connection back, and proxy behaves as the client itself. In here, for Facebook, the proxy behaves as a client, and for client, it behaves as a Facebook. Therefore, both sides are not aware of the proxy. You see, proxy certificate B, name C, signed by proxy root, certificate C, name C, signed by certificate authority in the internet PKI. Okay.
TLS inspection attack with rogue proxy server. Depending on network, attackers may be able to install rogue proxy. Rogue TLS inspect does not assume pre-installed proxy root certificate. Proxy creates fake server certificate with the name of external server, e.g. facebook.com. That e.g. can be self-signed. Fake server certificate is not validated, so browser asks user to accept it. Fake certificate has name equals domain name, so browser sets up TLS, and user believes that she has TLS connection to the external server.
The key point of a rogue server is that your browser asks you to accept certificate. So when you see such warning from your browser, it asks you to accept certificates, for example. Let me show you what I mean by that. Okay, for example, you will get an error like this. Your connection is not private. Attackers might be trying to steal your information from example.com. And when you click the advanced, it allows you to continue with this self-signed certificate or such. Therefore, you should never accept it unless you are sure about it.
Lenovo and the Superfish scam. Superfish root certificate and diversion in shipped Lenovo models during 2014. All HTTPS connections diverted to Superfish server to inject advertisements. Superfish created fake server certificates with names of web servers, e.g. facebook.com, signed by Superfish root private key. Fake server certificates were automatically validated, so users believed that she had secure end-to-end HTTPS connection to the web server. Scam discovered in 2015, Superfish cert. Deleted and diversion removed. Embarrassment for Lenovo. Superfish changed name to Just Visual.
So yeah, so you see, when a root certificate installed to your computer, then they may do anything they want, because your browser would automatically accept that certificate as valid and let you proceed. So this is a danger. For example, currently, when I open a website, my computer trusts the server certificate by Kaspersky. You see here, issued by Kaspersky Antivirus Personal Root Certificate. So in that case, it was a certificate by Lenovo. However, you were not aware that. I mean Superfish, not Lenovo.
Application Proxy Firewalls Plus and
This is positive sides and negative sides. The strengths are as follow.
Strengths, easy logging and audit of all incoming traffic, provides potential for best security through control of application layer data, commands. Weaknesses, may require some time for adapting to new applications, much slower than packet filters, much more expensive than packet filters.
Also, there can be privacy issues because your data is not anymore private, even if you connect through SSL port, because the system administrators can inspect and see your content.
Firewalls, simple firewall architecture.
So there is a firewall router. This is a gateway which connects your network to the internet, and there are internal networks such as DNS server, web server, email server, workstations, production systems, and database. So a firewall is a gateway that lets your systems to connect to the internet. This is the demilitarized zone. We have seen that.
Firewalls, DMZ firewall architecture.
So in the DMZ firewall architecture, there are two firewalls. First one is external router firewall, which lets your must be internet connected devices to the internet, here DNS server, web server, email server, and then it connects your demilitarized zone to your internal network with internal router firewall. Then there are workstations, production systems, and database server and such. So demilitarized zone example is like this.
DMZ equals a part of your LAN with other restrictions, e.g. allowing publicly available services, web servers, mail, etc.
So you see there is external public network internet, and then we have firewall external, then we have web server, FTP server. They are in the demilitarized zone, and then we have firewall internal, which connects our internal network, internal servers to our demilitarized zone servers such as web server or FTP server. Okay, now
Intrusion Detection Systems IDS.
IDS is intrusion detection system.
Intrusion Detection and Prevention. Intrusion, actions aimed at compromising the security of a target network, confidentiality, integrity, availability of resources. Intrusion detection, the identification of possible intrusion through intrusion signatures and network activity analysis, IDS, intrusion detection systems. Intrusion prevention, the process of both detecting intrusion activities and managing automatic responsive actions throughout the network, IPS, intrusion prevention systems, IDPS, intrusion detection and prevention systems.
Okay.
Intrusion detection systems. IDS are automated systems that detect suspicious activity. IDS can be either host-based or network-based. A host-based IDS is designed to detect intrusions only on the host it is installed on, monitor changes to host's OS files and traffic sent to the host. Network-based IDS (NIDS) detect intrusions in one or more network segments. To protect multiple hosts, monitor network s looking for suspicious traffic, what can be detected, attempted and successful misuse, both external and internal agents, malware, Trojan programs, viruses and worms, DOS, denial of service attacks.
So you see, an IDS system can even detect Trojan programs, viruses, or worms. Actually, Kaspersky Internet Security also does this. When you visit a web page, it checks the JavaScript code and some other codes or data on the website you are visiting and analyzes its content, and if it detects harmful scripts or such, it prevents you from connecting that website. Okay, so it is kind of behaving as an IDS.
Network IDS deployment.
Okay, we have external router firewall which connects our system to the internet. Then we have internal router firewall, and you see there are network intrusion detection systems, network based. So it checks the incoming traffic here, and also we have one here. So we ensure that both in demilitarized network and internal network, we try to detect the intrusion attacks. Okay. So what are the techniques?
Intrusion detection techniques. Misuse detection, use attack, signatures, need a model of the attack, sequences of system calls, patterns of network traffic, etc. Must know in advance what attacker will do, how, can only detect known attacks, relatively few false positives.
So this is based on the predetermined attacks actually, can only detect the known attacks. Therefore, it has relatively few false positives because it knows the attack signature.
Anomaly detection, using a model of normal system behavior, try to detect deviations and abnormalities, e.g., raise an alarm when a statistically rare event occurs, can potentially detect unknown attacks, many false positives.
Because this is the dynamic one, and based on the events occurring, it tries to detect an attack. For example, let's say your network usually gets 100 or 1000 incoming connections at any time, and let's say your system starts getting 100,000 connections at any given time out of nothing, and that is an alarming situation, because let's say you are operating a web server and some hacker may be trying to find vulnerabilities and exploits on your web server, try to crawl all your web forms and submit harmful codes to find whether your web server has, let's say, SQL injection vulnerability or such. So the anomaly detection is harder, and yet it may capture more type of attacks.
Popular NIDS. Snort, popular open source tool, large rule sets for known vulnerabilities, e.g., the 31st of March 2009, a programming error in MySQL server may allow a remote attacker to cause a denial of service (DOS) against a vulnerable machine. The 27th of March 2009, Microsoft Windows GDI buffer overflow, a programming error in the Microsoft Windows kernel may allow a remote attacker to execute code with system-level privileges. This may be exploited when specially crafted EMF files are viewed using Microsoft Internet Explorer. Bro, developed by Vern Paxson, separates data collection and security decisions. Event Engine distills the packet stream into high-level events describing what's happening on the network. Policy Script Interpreter uses a script defining the network's security policy to decide what to do in response.
Okay.
Example, vulnerability plus snort rule.
Okay, so this is a snort rule. It checks possible leak of kernel heap memory and take action according to that. Okay, anyway, let's continue.
Port scanning. Many vulnerabilities are OS-specific, bugs in specific implementations, default configuration.
This is so true. Hackers usually scan with automated tools to your system, and they check the already discovered vulnerabilities. For example, if you are using Windows Server 2000, let's say 3, and you have unpatched server, so they check that existing or discovered vulnerabilities in your server, whether you are using a patched version of Windows or not, or let's say you are using popular forum software such as MyBB, and they are checking whether you have fixed the previously discovered exploits or not. So they check based on your system, either your operating system or the software you are using.
Port scan is often a prelude to an attack. Attacker tries many ports and many IP addresses, for example, looking for an old version of some daemon with an unpatched buffer overflow. If characteristic behavior detected, mount attack. The art of intrusion. Virtually every attack involves port scanning and password cracking.
So, example, network services on Windows computer.
Example, network services on a Windows computer.
So you see these ports are listened by the Windows. What does listened mean? Listened means that the server periodically checks whether there are any incoming data from these ports, and if there are incoming data, it automatically accepts it and processes it. Therefore, if there is an exploit on that port previously discovered and you are using an unpatched Windows, therefore that exploit still remains on your Windows. So the attacker can exploit it without your intervention, okay, without your interaction. So this is about port scanning. Therefore, you should keep unused ports closed. That would improve your system security with prevention of previously discovered exploits or undiscovered exploits. Okay.
Intrusion detection problems. Lack of training data with real attacks, but lots of normal network traffic, system call data, data drift, statistical methods detect changes in behavior, attacker can attack gradually and incrementally, discriminating characteristics hard to specify, many attacks may be within bounds of normal range of activities, false identifications are very costly, sysadmin will spend many hours examining evidence.
Okay, probability density function, profile of intruder behavior and profiler of authorized user behavior. So they have overlapping behavior, and in this area you may block an authorized user or you may allow intruder. Okay.
Intrusion detection errors. false negatives, attack is not detected, big problem in signature-based misuse detection, false positives, harmless behavior is classified as attack, big problem in statistical anomaly detection, both types of IDs suffer from both error types, both false positives and false negatives are problematic, attacks are fairly rare events, IDs often suffer from base rate fallacy. Base rate fallacy. Consider statements. A. Attack occurs. D. Detection occurs. We can measure estimate P. D. A. Probability of detection, given that attack occurs. P. D. A. Probability of detection, given that no attack occurs. P. A. Probability of attack, we want to know false, true positives. P. A. D. Probability of attack, given that detection triggers Bayes' theorem. PAD equals P, D, A, P, A, P, D equals P, D, A, P, A, 47 P, D, A, P, A, plus P, D, A, P, A.
Okay.
Base rate fallacy. Example, scanner is 99% correct, P, D, A equals 0.99, P, D, A equals 0.01, attack probability, P, A equals 1/10,000th, PAD equals, result, 0.99 0.0001 48 0.99 0.0001 plus 0.01 0.9999 equals 0.010098 to 1%, accuracy 99 false positives per true positives.
So let's say you accept everything as a non-attack. In that case, you would have 99 accuracy, but you would miss that one attack. So this is Bayes rate fallacy. It is really hard to detect rare events in a lot of events. You may also find an explaining article to this.
The base rate fallacy, also called base rate neglect or base rate bias, is a fallacy. If presented with related base rate information, i.e., general information on prevalence, and specific information, i.e., information pertaining only to a specific case, people tend to ignore the base rate in favor of the individuating information, rather than correctly integrating the two. 1.
Okay, anyway, let's continue.
Remarks on intrusion detection. Most alarms are false positives, requires automated screening and filtering of alarms. Most true positives are trivial incidents, can be ignored. The attacks will never be able to penetrate any system. Serious incidents need human attention, can be dealt with locally, may require external expertise, potential for improvement through more intelligent IDs, less false positives, better detection of advanced attacks. Apt.
Okay.
Intrusion prevention systems. Intrusion Prevention System (IPS) is a relatively new term that can mean different things. Most commonly, an IPS is a combination of an IDS and a firewall, a system that detects an attack and can stop it as well, can be application-specific, deployed on a host to stop attacks on specific applications such as IIS, can be an extension of an NIDS. False positives are problematic, because automated prevention measures can block services.
When false positive happens, it means that you have blocked an authenticated user. So they are really problematic. And honeypots, which are extremely popular.
A honeypot is a computer configured to detect network attacks or malicious behavior, appears to be part of a network, and seems to contain information or a resource of value to attackers. But honeypots are isolated, are never advertised, and are continuously monitored. All connections to honeypots are per definition malicious, can be used to extract attack signatures. HoneyNet is an international security club. See next slide.
Okay, wireless LAN security. About honeypots, I will show you an article. Okay. Okay, there is an article on the Kaspersky.
What is a honeypot? The definition of a honeypot. One honeypot definition comes from the world of espionage, where Mata Hari-style spies who use a romantic relationship as a way to steal secrets are described as setting a honey trap or honeypot. Often, an enemy spy is compromised by a honey trap and then forced to hand over everything she knows. In computer security terms, a cyber honeypot works in a similar way, baiting a trap for hackers. It's a sacrificial computer system that's intended to attract cyberattacks, like a decoy. It mimics a target for hackers, and uses their intrusion attempts to gain information about cyber criminals and the way they are operating or to distract them from other targets.
Okay.
How honeypots work. The honeypot looks like a real computer system, with applications and data, fooling cyber criminals into thinking it's a legitimate target. For example, a honeypot could mimic a company's customer billing system, a frequent target of attack for criminals who want to find credit card numbers. Once the hackers are in, they can be tracked, and their behavior assessed for clues on how to make the real network more secure. Honeypots are made attractive to attackers by building in deliberate security vulnerabilities. For instance, a honeypot might have ports that respond to a port scan or weak passwords. Vulnerable ports might be left open to entice attackers into the honeypot environment, rather than the more secure live network. A honeypot isn't set up to address a specific problem, like a firewall or antivirus. Instead, it's an information tool that can help you understand existing threats to your business and spot the emergence of new threats. With the intelligence obtained from a honeypot, security efforts can be prioritized and focused. Different types of honeypot and how they work. Different types of honeypot can be used to identify different types of threats. Various honeypot definitions are based on the threat type that's addressed. All of them have a place in a thorough and effective cybersecurity strategy.
Okay, there are email traps or spam traps, a decoy database, a malware honeypot, a spider honeypot, and there are other things. If you want to learn more about them, you can read this article. Okay, let's continue to our lecture.
IEEE 802.11 Standards for WLAN. IEEE 802.11 formed in 1990s, charter to develop a protocol and transmission specifications for wireless LANs, WLANs. Since then the demand for WLANs, at different frequencies and data rates, has exploded. New ever-expanding list of standards issued, from 10 megabits per second to 1 gigabit per second transmission rate.
Okay, there is wireless, wireless station, our mobile devices, laptops and such, or IT devices, Wi-Fi security, and we have access point, our modem, and we connect to the internet.
(802.11) Wi-Fi security. Only authorized terminals or users may get access through wireless LAN. Should be impossible to set up rogue AP. Interception of traffic by radios within range should be impossible.
Okay, so that are the security, let's say protocols, web, VPA, VPA2. Usually, currently we are using all VPA2, and you see authentication and key generation, web, EAP, and encryption is RC4, RC4 authenticate, such. I remember that in 2000s you were able to decrypt Wi-Fi passwords just by gathering some random Wi-Fi data over with listening that Wi-Fi data transfer. It was possible. However, with recent authentication with VPA2, it is impossible. For example, I will show you.
WEP cracking. In order to crack WEP, we need first to capture the large number of packets. That means we can capture a large number of IVs. Once we have done that, we will use a tool called air cracking. This tool will be able to use statistical attacks to determine the key stream and the WEP key for the target network. This method is going to be better when we have more than 2 packets, and our chances of breaking the key will be higher. Let's look at the most basic case of cracking a WEP key. To do this, we will set Wi-Fi card in monitor mode. After this, we will run a command aerodump ing WLAN 0 to see all of the networks that are within our Wi-Fi range, and then we will target one of those networks, where WLAN 0 stands for the interface. The following output will be displayed after executing this command.
Okay, so it was so easy to crack web passwords. Okay, you see there's already a tool. Okay, however, recent applications all use VPA2, and which is extremely harder to crack, maybe impossible.
WEP, Wired Equivalent Privacy, Broken, WPA, Wi-Fi Protected Access, EAP, Extensible Authentication Protocol, RC4, Rivist Cipher 4, a Stream Cipher, TCEP, Temporal Key Integrity Protocol, CCMP, Counter Mode with CBC Message Authentication Protocol, RSN, Robust Security Network.
Okay.
IEEE 802 terminology. Station STA, wireless terminal that communicates with 802.11 functionality. Access point AP, receives radio signals and controls access to network. Basic service set BSS, set of stations and one AP. Extended service set S, set of multiple BSSs. Distribution system DS, contains an authentication server as integrates multiple BSSs into one S. Network components and architecture.
Okay, you see access point 1, basic service set, and there are the stations, and access point 2, and there are stations, and this is the distribution service.
802.11 IRSN services and protocols.
Okay, robust security network, RSN, access control, IAA 802.1, port-based access control, extendable authentication access authentication protocol, TKIP and CMP, confidential data origin authentication and integrity and replay protection, authentication and key generation, and access control. Okay. Cryptographic algorithms. This. Okay, so how the authentication happens? First, phase 1, discovery of access point. Phase 2, authentication with authentication service. Phase 3, key management. Phase 4, protected data transfer. And phase 5, connection termination.
(802.11 Wi-Fi access control). 1. Mutual identity request between STA and AP2. Mutual authentication between STA ANDs. 3. Derive pairwise master key PMK between STA and AP. 4. Encrypt radio link and open port connect to network access, controlled port from AP to network, is closed disconnected before authentication, is open connected after successful authentication.
You see at the first step we connect to access point, then there is going and incoming connection, and at the fourth step we get encrypted connection. You see a port is getting opened with the authentication server at the phase 2. Then there is a controlled port opened for our station, and from that port we communicate with the local network and then with the internet.
When you don't control the WLAN. Often you want to connect to a wireless LAN over which you have no control, e.g. in cafe options. If you can, connect securely, WPA2, 802.11i, etc. Beware of SSL stripping. If unsecured, connect to online resources securely. Use a VPN, virtual private network, IPsec connection to home gateway. TLS, SSL connections to secure web server with HSTS. Be careful not to expose passwords. Watch for direct attacks on untrusted networks.
End of lecture. Okay, so when you are connecting internet from an unsecured network, like from internet cafe or from your hotel room, if you are going to work on sensitive data, use a VPN. So VPN will increase your data encryption level, and also always use SSL. So if you use both SSL and a VPN, it is extremely unlikely, or let's say impossible, for that network administrator to see your content, see your data transmission. Okay, I think it is enough for this week. You get the idea of the topics. You can always look for articles to get more details. Okay, hopefully see you next week, and end of lecture.